A trash rack cleaning machine (TRCM) is a mechanical system designed to remove debris from the intake, screens or trash racks of water intake structures. These systems are essential in hydroelectric power plants, irrigation systems, water treatment plants, and other facilities where water is drawn from natural sources. The trash racks are metal grates installed in front of water intakes to prevent floating debris like leaves, branches, plastic, and other waste from entering the water system and damaging downstream equipment such as pumps and turbines. Over time, this debris accumulates and must be removed to maintain efficient water flow. The TRCM automates this task, reducing the need for manual labor and ensuring continuous operation. Introduction to trash rack systems. Purpose of trash racks. Trash racks are protective barriers placed at water intake structures to filter out large debris that could clog or damage internal components of water infrastructure systems. Without proper cleaning, trash racks can become clogged, leading to reduced water flow, increased pressure differentials, and potential mechanical damage. Importance of TRCM. The trash rack cleaning machine plays a crucial role in maintaining the effectiveness of these protective barriers. It ensures that water intake operations remain smooth, efficient, and uninterrupted, especially during periods of heavy debris flow such as during floods or storms. Components of a trash rack cleaning machine. A TRCM typically consists of the following components. Trash rack, a structure made of vertical or horizontal metal bars placed at the intake to prevent debris from entering. Rake arm, the component that physically removes the debris. It has teeth or fingers that engage with the debris on the trash rack. Winch or hydraulic drive, powers the movement of the rake arm, enabling it to move up and down. Guide rails or gantry, provides a path for the rake to follow, either fixed in one position or able to move horizontally to cover multiple bays. Electric motor and gearbox, drives the winch or hydraulic system to move the rake. Control system PLC HMI, automates the operation of the TRCM, allowing for manual or automatic control through a programmable logic controller and human-machine interface. Sensors, detect water levels and the presence of debris, can include differential pressure sensors, water level sensors, and debris load detectors. Debris disposal system, receives the debris removed by the rake, can be a hopper, conveyor belt, or chute that transports debris away from the intake. Working process of TRCM. The operation of a trash rack cleaning machine follows a systematic sequence designed to ensure maximum cleaning efficiency with minimal manual intervention. Monitoring and detection. The TRCM remains in standby mode while monitoring the condition of the trash rack. Detection is done through differential pressure sensors. Measure the water pressure difference across the trash rack. A rising differential indicates clogging. Level sensors. Monitor upstream and downstream water levels to detect obstructions. Debris sensors. Identify physical presence of debris on the rack. Activation of cleaning cycle. When the sensors detect critical level of debris or the system is manually activated, the cleaning cycle begins. Activation can be automatic, based on sensor data, scheduled, set intervals regardless of sensor readings, manual, initiated by an operator from the control panel or SCADA system. Positioning the rake. Depending on the type of TRCM, fixed type, the rake cleans a single location. Traveling type, the rake moves horizontally along a gantry to clean multiple sections or bays. The rake is positioned at the top of the trash rack in front of the area needing cleaning. Descent of the rake. The rake arm is lowered down the face of the trash rack by the winch or hydraulic cylinder. The rake remains in contact with the rack, and its teeth or fingers engage the debris as it moves downward. Collection of debris. As the rake descends, it collects debris stuck on the trash rack. The teeth comb through the gaps between the bars, dislodging and catching waste materials. Lifting the debris. Once the rake reaches the bottom of the trash rack, it is pulled back up, carrying the debris with it. The lifting mechanism ensures the debris remains trapped in the rake until it reaches the top. Debris discharge. At the top of the cycle, the rake moves over a discharge area. The debris is released into a trash bin for manual disposal, a conveyor system for continuous removal, a chute or flume that carries the debris downstream. Debris is typically discharged by rotating or tilting the rake or using a mechanical pusher. Reset and repeat. After the debris is discharged, the rake returns to the starting position. If the system is cleaning multiple bays, it moves horizontally to the next section and repeats the cycle. Control and automation. Modern TRCMs are highly automated for efficiency and safety. Programmable Logic Controller PLC controls the sequence of operations, including rake movement, motor speed, and sensor readings. Human-machine interface (HMI) allows operators to monitor system status, view sensor data, and manually override automatic functions. SCADA integration, supervisory control and data acquisition systems enable remote monitoring, data logging, and alarm handling for TRCM operations. Types of trash rack cleaning machines. Fixed rake TRCM cleans a single section. Simple, cost-effective, suitable for small intakes. Traveling rake TRCM, mounted on a gantry, moves horizontally to clean multiple sections. Ideal for large-scale installations. Advantages of TRCM. Reduced manual labor. Automation reduces the need for human operators. Improved equipment protection. Prevents debris from reaching pumps and turbines. Remote monitoring allows for centralized control and real-time status updates. Safety reduces the risk of injury associated with manual debris removal. Installation and commissioning. Site preparation. Survey the intake area. Install mounting brackets and guide rails. Ensure structural stability. Equipment installation. Assemble and install the rake, winch, motors, and gantry. Install the control panel and connect power supplies. Testing and calibration. Perform dry and wet test runs. Calibrate sensors and limit switches. Set automatic cleaning thresholds. Maintenance and troubleshooting. Routine maintenance. Lubricate moving parts. Inspect rake teeth and replace if worn. Check hydraulic fluid levels. Clean sensors and control panels. Common issues. Rake jammed, caused by large or heavy debris. Check for obstructions. Sensor malfunction. Recalibrate or replace faulty sensors. Motor failure. Inspect electrical connections and motor windings. Hydraulic leaks. Tighten fittings or replace hoses. Safety features. Emergency stop buttons, located near the machine and in control rooms. Overload protection. Detects excessive resistance and halts operation. Limit switches. Prevent overtravel of rake. Interlocks. Ensure safe operation during maintenance. Environmental and regulatory compliance. TRCMs must comply with environmental guidelines to ensure they do not adversely affect aquatic ecosystems. Measures include safe disposal of collected debris, noise reduction features, minimal disruption to aquatic life during cleaning. Case study: TRCM in a hydroelectric plant. At a hydroelectric plant with a high debris load. A traveling type. TRCM was installed across a 20-meter wide intake channel. The system included dual rakes operating in alternating cycles, PLC-controlled automation, conveyor system for debris disposal, remote SCADA integration. Results: 40% reduction in maintenance downtime, improved turbine efficiency, increased safety for maintenance personnel, renewable power integration, solar-powered TRCM for remote or off-grid sites. Conclusion: the trash rack cleaning machine is a vital component in modern water intake systems. By automating the debris removal process, it enhances operational efficiency, protects critical infrastructure, and minimizes human intervention. With advancements in automation, sensor technology, and remote monitoring, TRCMs are becoming increasingly sophisticated, making them essential for reliable and sustainable water management.